The title for our case study 1 is Finding Market Equilibrium using Cramer's Rule, and our second case study is Solving Problems using Gauss-Jordan Elimination Method. First, I will talk about introduction to case study 1, which is Finding Market Equilibrium using Cramer's Rule. In economics nowadays, it is too hard for the concept of market equilibrium to understand how the markets function. So, to comprehend how markets function, one must grasp the economic idea of market equilibrium. When a product's quantity provided and demanded are equal, market equilibrium arises, maintaining the product's price stability. Our case study objective is to use Cramer's Rule to ascertain the equilibrium quantity and price for two linked products which are pens and paper by applying the rule. The supply and demand functions that have been provided allow us to determine the exact price and quantity at which the market for this product will be in equilibrium. This approach provides valuable insight into the behavior of linked items in markets while reinforcing the usage of linear algebra in economics. Next, I will talk about introduction to solving problems using Gauss-Jordan elimination method. Solving complex problems requires the use of dependable techniques from linear algebra to solve system of linear equation. The reduced row echelon method (RREF) in Gauss-Jordan elimination method is considered one of the most effective methods for solving these types of problems. In this case study, the use of RREF techniques to address the reward issue in a variety of settings, including ticket, food, and transportation costs, is described. We can find the solution systematically by transforming the system of equation into metric form and using simple row operation. The practical application of linear algebra demonstrates its versatility and effectiveness in addressing real-world problems. While also simplifying the solution process for linear equation, this case study will provide insight into the practical implementation RREF in Gauss-Jordan elimination method.
We have two purposes of study. For case 1, to find the equilibrium prices and quantities for each good where the supply and demand function are given. Then to solve the problem by using the Cramer's Rule. For the case 2, first, to determine the interest fees for children, teenagers and adults based on the total fees paid by different groups. Then to find the fare for bus, taxi and bus service based on the total fare collected for different combination of passengers taking this service. And the last one is to determine the price of a curry puff, donut and nugget based on the total prices given by different combination of this item. Then to solve the problem by using Gauss-Jordan elimination method. Case study 1, find the market equilibrium using Cramer's Rule. The question is the demand and supply function for two related products. First is pen and second is paper, and we need to using the Cramer's Rule to find the equilibrium prices and quantity. First, we will use the formula Q demand equal to the Q supply, and we need to collect the P to the left, so we will get negative for P1 plus for P2 equal to the negative 36. Same method goes to the paper, then we will get 3 P1 minus 40 P2 equal to the negative 40. So we will take the both equation as the reference when you use the Cramer's Rule. Next step is apply Cramer's Rule to find each product price. For P1, we get 50.09 and P2 is 6.09. Then we will substitute this value for P1 and P2 into the original equation to solve a QD1 and a QD2. And we will get QD1 equal to the 39.27 quantity and QD2 equal to the 69.09 quantity.
Okay, first we must set up an equation where the supply and demand equation for the three goods. And second, set the supply equal to demand for each good to get the three equation. Arranged in standard form, we have the equation in the form metric form. Represent the equation in metric form AX equal to B, where A is the coefficient metric, X is the variable metric, and B is the constant metric. And we use Cramer's rules to solve for the price. And find the price, calculate using the determinant. Use the price form to calculate equilibrium quantity using the supply equation.
The study case 2, question 1. In a visit to an exhibition center, Group A, which consists of 3 children, 2 teenagers and an adult, paid a total entrance fee for RM91. Group B, which consists of a child, 3 teenagers and 2 adults, paid RM140, while Group C, which consists of 2 children, a teenager and 4 adults, paid RM138. Find the entrance fee for a child, a teenager and an adult. We need to solve the problem using Gauss-Jordan elimination method. Firstly, from the problems, we need to declare X as child, Y as teenager and Z as adult. Then form it into equation and augmented metric. After that, we use elimination row operation until we get REF or RREF. In this case, we use ERO until we get RREF. Lastly, we get the entrance fee. For a child is RM10, for a teenager is RM18, and for an adult is RM25.
A transport company provide bus, taxi and van service to send student to school and adult to work. If a person take the bus, another person take the taxi and a third person take the van, the total fare collected by the transport company is RM25. If a person take the bus, two people take the taxi and three other people take the van, then the total fare collected is RM49. Finally, if two people take the bus, a person takes the taxi and other person takes the van, then the fare collected is RM32. Find the bus, taxi and van fare for one person. So we can solve this problem by using Gauss-Jordan elimination. Step 1, we will let X as a bus, Y as a taxi and Z as a van. Then we can transform the data into the equation such as X plus Y plus Z equal to 25, X plus 2Y plus 3Z equal to 49, 2X plus Y plus Z equal to 32. Next, we can transform that into the augmented matrix since we will use Gauss-Jordan elimination to solve this problem. So that we will solve the RREF. Then after done with RREF, we will convert this matrix to a corresponding system of a linear equation so that we will get S equal to 7, Y equal to 12 and Z equal to C. For the final answer, we will get fare for bus is RM7, taxi is RM12 and van is RM6.
Okay, for case 2 question 3, the price of 2 curry puff and a donut and tea nugget is RM2.18 and the price for a curry puff and 2 donuts and 4 nugget is RM30.30. If a person buy 3 curry puff, 4 donuts and a nugget, then he needs to pay RM4.30. Find the price of curry puff, a donut and a nugget. First, we must to declare X equal to curry puff, Y equal to donut and Z equal to nugget. Okay, second we write in the equation and then we using ERO and we get RREF. Okay, for the curry puff we get 50 cent, donut we get 60 cent and nugget 40 cent. For the discussion for case 1, based on the purpose, we need to find the market equilibrium using Cramer's rule for the given supply and demand equation. For question 1, we get the answer P1 is 50.09, P2 we get 6.09 and for Q1 we get 39.27 Q2 we got 69.09. For question 2, we get the answer P1 is 7, P2 is 9, P3 is 10 and Q1 we get 51, Q2 we get 103, Q3 we get 39. For the discussion for case 2, based on the purpose, we need to find the entrance fee for a child, a teenager and an adult. After calculated and using Gauss-Jordan elimination method, we get the answer for the entrance fee is RM10 for child, RM80 for teenager and RM25 for adult. Based on the purpose, we need second question, based on the purpose, we need to find the bus, taxi and van fares for 1%. After calculating and using Gauss-Jordan elimination method, we get the answer for the fares is RM7 for the bus, RM12 for taxi and RM6 for van. Okay, for the last question, question 3, based on the purpose, we need to find the price of a curry puff and a donut and a nugget. After calculating and using Gauss-Jordan elimination method, we get the answer for the price is 0.5 for curry, 60 cent for donut and 40 cent for a nugget.
Conclusion, we can conclude that we determine the equilibrium prices and quantity for each set of product in case study 1 by using Cramer rule. For the first set of product, which is pen and paper, and the second set of product, we solve it with the linear equation using Cramer rules. Next, in a case study 2, we need to solve 3 different problems that involving system of equation. For all 3 questions, we solve it using Gauss-Jordan elimination. And for the first question, we need to find the entrance fees for a child, a teenager and an adult. So we get RM10 for a child, RM80 for teenager and RM25 for adult. For the second question, we need to find transportation service fare by company that providing a bus and a taxi and a van. Then we get RM7 for a bus, RM12 for a taxi and RM6 for a van. For the last question, we need to find the price of food such as curry puff, donut and nugget. So we get 50 cent for each curry puff, 60 cent for each donut and 40 cent for nugget. This assignment shows us that Kramer rules and Gauss-Jordan elimination can solve various economic and real-life problems, and we can understand that mathematical method also can be applied in everyday problems and situations.